In this question, there's a spacecraft are used to carry crew and supplies to international space stations. Spacecraft consist of rocket, fuel tanks, capsules, and to carry to, the crew and the supplies. As you can see, the capsule and the rocket. During the takeoff combustion, hot gases are there at very high pressure. The gas expand and move downward out from a rocket. Explain how this enable spacecraft to accelerate away from the ground. So what will happen? Like example, these are the gases. The hot gases are coming out due to a combustion. So as a result, when these hot gases are coming out, the hot gases will exert an upward force. Because according to Newton's third law, action and reaction forces are equal but opposite in direction. So there is a force on the gas particle which is outward, and as a result, gas particle will exert an upward force on the rocket. And when it exerts upward force on the rocket, so when we compare for a rocket, the weight is acting downward, the gravitational pull is downward, and due to the force from the gases, that is upward. And that force, upward force, is more than the weight. As a result, when upward force is more than the weight, so F minus W will be equal to MA, or it will create a resultant force which will be equal to MA. So how these gases enable this spacecraft to accelerate upward? So answer here that the gases exert upward force on the rocket, and which create or upward force is more than the gravitational force or weight. So this will produce resultant force. So the rocket will accelerate. So this is basically what happened for the rocket, that gases exert an upward force on the rocket. As a result, there's an upward force more than the gravitational force, which is downward, and that create a resultant force, cause this rocket to accelerate. As the spacecraft take off, the apparent weight of the crew member is 3,700 Newton. Determine the expression. Mass of the crew member is 81 kilogram. So what will happen? We have to determine the acceleration. So the upward force minus the downward force is equals to ma. Apparent weight. So this is not the actual weight, this is the apparent weight, which is 3,700. Or we can also say the normal contact force is 3,700. So the normal contact force R, that is 3,700 Newton. The downward force, that is equals to weight multiplied by mass into gravity. And the resultant force will be equal to R minus W. So in this case, the upward force is R and the downward force is W. And so R minus W is equals to, according to Newton's second law, equals Ma, where R is a upward force 3,700 minus the weight, which is the downward force, equal to mass into gravity. The mass of the crew member is 81 and the acceleration due to gravity is 9.81. So this will be 81 times 9.81, and that is equals to 80. Mass is 81 and acceleration we don't know. So we subtract and then divide by 81. This will give us the acceleration of this spacecraft, which is about 36 meter per second square. Next part, As each fuel tank becomes empty, the tank and its associate rocket are detached from the spacecraft and fall back towards the Earth. Explain why this is done. So what is the reason for that? Because when the fuel is used up, the remaining part fall back to the Earth. So that will reduce the mass of the spacecraft, and the mass, as a result, when the mass decrease, what will happen? The acceleration will increase. So when the parts of the spacecraft detach, as a result, what will happen? The total mass will decrease. As a result, mass will decrease. Mass and acceleration are inversely proportional. So if mass is decreasing, acceleration of a spacecraft will increase. In part D, when the capsule returned from International Space Station, parachutes are used to reduce the speed and the capsule as it's near to the surface of Earth. Explain how parachute reduces the speed of the capsule. So this is like explaining a motion of a falling object with air resistance. So what will happen when spacecraft or space shuttle opening its parachute? It will have a large surface area. When it will have a large surface area, so it will experience greater air resistance. As it experiences greater air resistance, so more upward force than the downward force, or we can say, because that is the direction of the motion. Direction of the motion is downward, but upward force is more than the weight. As a result, when upward force is more than the weight, or the frictional force is more than the weight, what will happen? The resultant force is in opposite direction. So if resultant force is in opposite direction of the motion, the spacecraft will slow down. So the parachute will have a large area. As a result, when it will have a large area, it will have a greater air resistance or a drag force, we can also say. And when there is a greater drag force, there is a resultant force upward, opposite to the direction of the motion. That's how this parachute will. That's how this space or the capsule, when it returns, it will slow down. So large area reduce or increase the surface area. Large area increases the air resistance, or we can say drag force, which create resultant force upward. As a result, when there's a resultant force upward, what will happen? Resultant force upward. So the resultant force opposite to direction of motion. So the capsule will slow down.